Okay. So if we keep on going, once again, you can either plug it right in, you can distribute the limit as x approaches -2 of x cubed plus, I'll just go ahead and factor the 2 right out, 2 times the limit of x squared as x approaches -2 minus the limit of 1 as x approaches -2 over the limit of 5 as x approaches -2 minus the limit, I'll bring the 3 right on out, the limit of x as x approaches -2. And you probably already have the answer, but we're going to keep on going. If you plug this right on in here, -2 to the third plus 2 times -2 squared minus the limit of any constant is just that constant. The limit of that constant is just that constant. Minus 3, the limit of x as x approaches -2 is -2. Okay, so here we have -8. -2 squared is 4, plus 4 is 8, minus 1. Oh, make sure, yep, still up there. Over 5 minus -6, which just makes that +6, which is -11, well, -1 over 11. Okay. Any questions on that one? All right.
What was that answer?
Oh,
Sorry.
-1 over 11. All right. Okay. Now this is where we get into not every limit exists. We're going to look at piecewise functions, or the limits of piecewise functions. Okay. So we know that a limit only exists if its limit from the left and the limit from the right are both equal. Okay, you can't have a limit exist if it's 5 when it's coming from the left and -2 if it's coming from the right. They would have to both be the same for it to exist. Okay. That's one of those rules that will come back later on over and over and over and over again. Limits only exist if they are the same when approaching a constant value of c from the left and right. Whoop, clean that up. Oh, sorry about that. Okay, so let's say if we have, for example, find the limit of, say, the limit of absolute value of x over x as x approaches 0. Okay. So we know that if you're approaching 0 from the left, whatever x is going to be negative. So everything over here is just negative x, and everything over here is just positive x. All right, so let's say if we're approaching 0 from the left, this is the approaching from the left, then that means that will be a negative x at the bottom. It will be absolute value of negative x over negative x. As x approaches 0, and we'll actually get into that terminology in a second, but from the left, it will be like a little exponent of a negative sign. That's when you're approaching it from the left. Okay, that would actually equal the absolute value of negative x is still x, because it's the absolute value. But when you plug in the negative x here, it would just be a negative x. So you end up with a limit of -1. Okay, but if you have, when approaching 0 from the right, then that means you're just going to have a positive x. So you have the absolute value of a positive x over a positive x. So as x approaches 0, and when you're approaching from the right, it's just a plus sign. Okay, so that's just going to be x over x, which is 1. Okay. So because they're different, that means it doesn't exist. Yep, here. Move that up a little bit. Yep. So it does not exist. And normally if it does not exist, you'll see D and E. And the only reason it doesn't exist is because when you approach it from the left and from the right, you have two different values. So the limit of absolute value of x as x approaches 0 from the left does not equal the limit absolute value of x over x as x approaches 0 from the right. Okay. Now, if they were equal, then they would have the same limit. Okay. Any questions on that one? All right. Oh, I'll let you finish writing that one down. All right. Okay, so let's do one more absolute value problem. Okay, so let's say we want to find the limit as x approaches -7 of 5 times x plus 7 over -2 times absolute value of x plus 7. Okay. Now with this one, because it's a little bit different, you're approaching, you're not just having an absolute value of x, it's kind of a little bit tricky. What I do with these is either you can graph them and see, and you'll see how it looks completely different if you graph it, or you can pick a value really, really close to -7 from the left and really, really close to -7 from the right. And you'll see if they're not the same, then the limit doesn't exist. But if they are the same, then it does exist. So that's one way to get past problems like this that are really kind of tricky. Instead of having to go through all that absolute value of this and absolute value of that will be x and not x, just get a value really, really close. Because as it's getting closer and closer, if they're not the same, it doesn't exist. So let's try that. So first thing we want to do, well, actually we can bring that -5 over 2, we can factor that out. We don't have to have that there. So we can pull the constant. out to the front. Okay, so we have negative 5 over 2, just factor that right on out, times the limit of x plus 7 over absolute value of x plus 7 as x approaches negative 7. Okay, so we know we can't just plug it in with direct substitution because we'll have a denominator of 0. So now we have to go another way. Okay. So the easiest way for this problem is to pick a value approaching negative 7 from the left and right. Okay, so just on our number line, if we have our negative 7 here, from this direction, from the left, we'll pick x equals negative 7.01. That's really close to negative 7. And when we're approaching this direction, so x approaching from the right, we'll pick x equals negative 6.99. Again, really close to 7, but negative 7, but not equaling negative 7. You know, we can always get a little closer and a little closer and a little closer, but that's close enough for our answer. Okay. So when, make sure that's up enough. Okay. So when x is equal to negative 7.01, that gives us negative 5 over 2 times the limit of negative 7.01 plus 7 over the absolute value of negative 7.01 plus 7. And really, you could have left the limit off of it because this is just going to be a constant. So the limit of whatever constant this is just going to be that limit. So once you plug in an x value, you could have left the limit off of it. Okay, so we have negative 5 over 2. Negative 7.01 plus 7 is negative 0.01. And negative 7.01 plus 7 is negative 0.01, but the absolute value of that would make it positive. So that would be positive 0.01. Okay, so negative times negative is positive. Anything divided by itself is just going to be 1. But this is going to be negative 1 since the signs are different. So you have negative and negative, which is positive, so that's positive 5 over 2. Okay, so now we can try the other one. Oh, make sure that's up front. There we go. So if x equals negative 6.99, again, we have our negative 5 over 2 times, of course, if you want to leave the limit off, you could, but I'll put it in just as habit. So negative 6.99 plus 7 over the absolute value of negative 6.99 plus 7. Okay, so that's going to equal negative 5 over 2. Negative 6.99 plus 7 is positive 0.01. And the absolute value of that is also positive 0.01. So anything divided by itself, of course, is going to be 1. Gives us an answer of negative 5 over 2. Okay, so if you have 5 over 2 in one direction and negative 5 over 2 in the other direction, then you know that the limit doesn't exist. Because they have to be the exact same. Okay, so the limit, you see, does not exist since one side well, one side of the limit is different from the other. Okay. Any questions on that one? Yes.
So do you have to necessarily like put the direction like with the limit as x approaches -7, would you have to put the little like positive or negative at that point, or is it okay to just leave it out?
Well, you can leave it out only because we really didn't approach it from that one. We just grabbed the value of x and plugged it in.
Oh, okay.
So if you were actually approaching it from that direction, then you would have probably put it in. It wouldn't hurt to put it in since that's what you were doing. But since that ends up being a constant, it just kind of disappears anyway.
Oh, okay.
Okay. Any other questions? All right. Okay. And we're going to continue with our little note here. Okay. In every situation, a limit can exist even if the value at that point does exist. What I mean by that is, up till now, whenever we plugged in the value for 0 or something else, or as x approaches 0, it would always be at some point where it didn't exist. It doesn't always have to not exist. Sometimes it'll exist and still not be a limit. And I'll show you what I mean by that. The existence or non-existence of f of x at x equals c has no bearing on the existence of the limit. Clean that up a little bit. Of f of x as x approaches c. Okay? So hopefully it'll make a little more sense when you see an example of that. Okay, so if we want to say find the limit as x approaches 2, such that f of x is equal to 1 when x doesn't equal 2, and 0 when x does equal 2. Okay, so if we were to graph that, we have our x and we have our y. We know as x approaches 2, well, when x doesn't equal 2, let's say this is our 1 and this is our 2. X is equal to 1 everywhere else except when x is equal to 2. Okay, so here you just have this horizontal line with this one missing point, because that's where it's just equal to 1 everywhere except that point. But when x does equal 2, your y value is 0, which means it exists down there. Okay. Now, if you notice, as x approaches 2 from the right and it approaches 2 from the left, the limit is still 1. So the limit of f of x as x approaches 2 from the left is equal to the limit of f of x as x approaches 2 from the right. Okay? They both exist. They have the exact same limit, which means they both equal 1. Okay? So it also means just because the limit exists, you know, you can have a limit exist and still not be the exact same as if you just plugged it in. So even though the limit exists, it doesn't mean that it's always going to be at that point. The 2 does exist. It just doesn't exist on that particular limit. Does that make sense? All right. Okay. All right. So, make sure that's up. So the limit exists. And the value is defined at x equals 2. Okay. All the other ones that we had before, it had some undefined value, but this one has a defined value. Okay. Any questions on this one? All right. Okay, so let's do a few more piecewise examples. Oh, thank you. Okay, so we want to find the limit for f of x where, say, f of x equals 2x plus 3 when x is less than 2, and it's equal to x squared plus 1 when x is greater than or equal to 2. Okay, so the first thing we want to do is we want to find the limit of f of x as x approaches 1. And B, we want to find the limit of f of x as x approaches 2. Okay. So before we start, the first thing we want to do is we want to get a clear understanding of what we have as far as the piecewise go. Okay, so if we can do A is actually pretty straightforward. We just have to look at our number line. And we know that if this is 2, our x is less than 2, means we're approaching 2 from the left. Yes?
Can you go back a little bit more? I didn't catch all of that.
Oh, sorry about that. All right. And we know that when x is greater than or equal to 2, you're approaching 2 from the right. Approach 2 from the right. And this one is approaching 2 from the left. Okay. So for our piecewise functions, it all depends on these conditions right here. Once you get those conditions kind of written down and understood, you'll know how you're approaching it. So we know that if we're approaching 2 from the left, we're going to use 2x plus 3. And if we're approaching it from the right, we're going to use f of x equals x squared plus 1. Okay. Does that make sense? Yes.
Why do we have to find out the limit of f of x when x approaches 1?
Yeah, that's what I was thinking.
Oh, because you have to figure out which f of x you're going to use. Because remember, if x is approaching 1, then you're right here.
Right.
Which means you're approaching 2, so all you have to do is just plug 1 in. But you have to remember, you have 2 different f of x values. So you know if it's approaching 1 from this side, you're going to use this one.
Can't you just solve it by doing just the B without having to do A? Like having to find the limit if X.
Oh yeah, for A you can just plug it in. But I'd say you just have to figure out which one you have to use to plug in. Yes.
I think he was saying is that he didn't understand that A and B were like the questions, and then you have to use the stuff from up top to determine the answer.
So let me see, make sure I'm understanding. So you're saying the
So A is B is part of the question, right?
yes.
Okay, so that was a whole question.
Mm-hmm.
Okay, I thought it was like the steps that you use.
Oh.
Oh, okay, I see what
Oh,
you're
you
saying.
see, that's why I was confused.
Oh, okay, I see what you're saying.
So A is one question, B is another.
B is a separate question.
Yeah.
Oh, okay, yeah, I
That's
see.
why-
Okay.
There we go.
Okay. Yeah, with the question, what they were asking, they gave you the f of x, but they didn't tell you as x approaches what.
Okay.
So when they say just find the limit, if they don't tell you as it approaches this or approaches that, then it's just find the limit of what, where. So A and B kind of tells you, okay, find the limit here, then B is find the limit here. So,
So because A is 1
Mhm.
and it's less than 2, so
Yep.
therefore you use.
yep, you'd use this one. Okay, so for A,
You pretty much just plug in the one for the X.
yep, you can just plug it in. Since x is less than 2, when the limit as x approaches, well, x approaches 1 is less than 2. So that should go right there. Okay. So we're going to use f of x equals 2x plus 3. Okay, so we just have to find the limit of 2x plus 3 as x approaches 1. Okay. Since it won't make anything undefined if we plug it in, we just plug it in. So 2 times 1 plus 3, which is 5. Okay. Any questions on that one? No, usually the piecewise are the confusing parts of it. Yes.
So the piecewise is just like a set of rules that we have to follow.
Exactly.
Okay.
So you have really these two conditions. So depending on which condition you have, it would base on which f of x you'd use. Okay, I'm trying to think if I have enough room for this one. I probably I might be able to make it fit. But nah, I don't want to. Nah, it won't fit. I'll have to put it on another sheet. Oh, I'll give you a few minutes to finish writing that. Mm-hmm.
Going back to A, how come this is going back to when you chose 1 to
Mhm.
use as x is approaching 1, how come you didn't choose the same as the other one when x is approaching 2, since it's still technically approaching 2 from the left?
Yep, because
Chose
when
1.
it's greater than equal to 2,
Oh,
it's
that's
also,
right,
yep,
never mind.
it's
Yeah,
approaching
that's
from the
a
right too.
question. Never mind.
So you just have to make sure the limit from the
Yeah.
left and the right are both the same. All right, anybody got that? Yeah, all right. Okay, so we'll go ahead and finish B. Oh, let me bring that down a little bit. Let me see. I'll put that right underneath it. Okay, so for B, since 2 is being approached from the left and right,